Hey guys, here we are for Chapter 19. Now Chapter 19 is climate change, as is Section 19.1. Now in environmental science, it's not all about climate change, but whenever you talk about environmental science, climate change is definitely kind of on the top of the list of what people associate with it. So we want to make sure that we really give it due course. Now, as always, a chapter start, we kick off with a core case study. The rising sea levels. Once again, climate change, there are many things that can occur. We'll look at them, what occurs, but right off the bat, the rising sea levels. Now we're going to reference the IPCC. This is the Intergovernmental Panel on Climate Change. Many governments have come together. We've put scientists and other people together on this panel, and it is their job to really look at climate change, post what evidence is happening, predictions that we think are occurring, etc. So a lot of what we'll talk about is coming from this Intergovernmental Panel on Climate Change. Now their findings, their conclusions, if you will, after looking at the data and research and all the science involved, is that Earth's climate is changing rapidly. And it's human activities that are the dominant cause, not the only cause, but the dominant one. And that climate change cannot be stopped, but that it can be slowed. We've reached a point where some of this is going to continue no matter what, but there are some things that we can do to slow it down, to keep it from going as quickly. And as a general rule, the slower change happens, the easier it is for everyone to adapt. It could be plants, it could be animals, it could be humans in cities, etc. Change is fine, but the slower the change occurs, it allows us time to adapt to the new realities. Now, along with the climate change comes warmer oceans and melting of glaciers. And when we come to melting of the glaciers, well, that's ice that's going to, it's now trapped up in ice, but it's going to release into the oceans, which tends to lead to future flooding of a lot of low-lying islands and then these coastal areas. Down in the Keys, we've already seen areas where they've grandfathered it in. If a storm comes and it gets destroyed, you can't build on that area because the water is just coming up and encroaching. And in other very low-lying island nations, they've seen this as well. In Greenland, in this core case study looking at rising sea levels, Greenland is something that we very specifically are keeping our eye on because the glaciers just on Greenland alone, now it's a huge mass, but has enough water in them to raise sea levels by 7 feet. So this is a massive amount of ice that we're looking at in Greenland. Take a look at the picture back here. This is Greenland in the summer of '82 and Greenland in the summer of 2012. The red is showing the ice melt. So at the peak of summer in '82, the red is the part of the ice that melted. Summer, winter, right? Some of it melts, some of it stays. Well, look at the difference between '82 and 2012. It's not a coincidence we're talking about 30 years because that's what we talk about affecting for climate. So a lot of difference in snowmelt in a 30-year change. So Greenland is just one of these areas that we look at, and it's a caution because the amount of ice on that one island or continent, if you will, is enough to drastically affect the sea levels around the planet. Now, Section 19.1 proper is climate change, same as the chapter title. And the scientific evidence strongly indicates that the Earth's atmosphere is warming at a rate that is likely to lead to significant climate change. Now, let's make sure we address the difference between weather and climate. This always gets me every year, or at least for the past 5 or 6 years. I hear some senator or some politician or even a president saying something like, well, it's awfully cold out there now. That was a record-setting cold day. That's weather. Weather are short-term changes. That's what's going on out there right now is weather, or what's going to happen next week, or what happened in one day 20 years ago is weather. Climate is the average weather conditions over a particular area, Gainesville, Norway, Iceland, Greenland, Japan, over 30 years or more, 30 years, 100, that we look at. So when we're talking about a weather event happening today, it's weather, and it doesn't factor into our research over climate change. And climate, we're collecting data over a 30-year period and looking at it and say, is the climate different over this 30-year period, say from 82 to 2012, compared to 72 to 2002? We can look at what is the climate here, here, and here. So make sure you pay attention to the difference in weather and climate. Past and recent climate change. Climate change is nothing new, right? Florida was covered in water at some point in time in the past. The sea levels were higher. Florida is exposed now. We have had ice ages. The whole planet's been more jungle-like in the past. Climate change is something that's occurred throughout history. It's nothing new. So we can learn from it by looking at past changes and at recent changes, and then draw correlations between them. Now, factors that have altered our climate over the past 3.5 billion years. Now, it's not like we had temperature sensors out there, but we can pull ice cores up. We can look at the gases that were trapped in the ice at the time down in deep ice cores at different time frames and segments. And rock data, we have lots of data, fossil records that we can assess and begin to piece together changes that have occurred. Now, in the past, a lot of time it's been large-scale volcanic eruptions, impacts by meteors, things that killed off the dinosaurs, asteroids, changes in the solar input, right? We have solar maximum, solar minimum. Now, normally we talk about that over its 11-year period, but that's a minimal one. It also has a much larger 100,000-year period as well. So we'll look at some of these factors as we go in. Change of the shape of the orbit of the Earth, changes from very circular to slightly more elliptical over really long periods of time. And all of these are factors that affect our overall climate change. Just like we talk about the El Nino event and the Pacific decadal cycle, and have there been volcanic eruptions, and is it solar maximum minimum? These are all things we look at how the weather is getting affected for this year or two, because those tend to be fairly short term, over less than a decade as a general rule, but they factor into these overall climate shifts, and we have to look at it all. Now, when we look at climate fluctuations over the past 900,000 years, we have had both glacial, like an ice age, and interglacial periods between ice ages where it tends to warm up. So when we talk about it over this 900,000 period of time, we'll talk about glacial periods and interglacial periods. Now, we have been in an interglacial period for the past 10,000 years. And that number is somewhat significant because that's about the time the agricultural revolution began. We're kind of coming out of an ice age, and temperatures were warmer, and this sort of spurred, if you will, our agricultural revolution. The temperatures have been fairly stable over the past 1,000 years, once again, just looking at all the data. Now, atmospheric temperatures have been rising since about 1975. When we look and track the data, that's just the line in the sand. From that point on, we see, climate speaking, long periods that the temperatures have been rising. And we are attributing this to the rising inputs of greenhouse gases. Once again, for a hypothesis to be functional, we research, it has to be based on something we know, based on something we've seen, and it needs to follow from logical consequence. Greenhouse gases can capture, hold, and re-radiate heat. The more greenhouse gases we have in the air, the more heat they can capture and the more they can re-radiate out. So greater greenhouse gases leads to a greater warming of the planet. We know that's why the planet's warm anyway. Overwhelming natural factors led to these changes in the past. Volcanic eruptions, asteroid, various things coming in. So we want to look at some of this past data along with what we see now. I'm putting a chart up here. This chart is, let's start at the one on the left, high peaks up and down. This is in thousands of years. So it starts at 900, comes all the way up to present, and we're talking in terms of thousands of years, 900,000, moving along. And we can see these large general peaks of it moving up and down. Now, if I'm looking at it, the lowest peaks are, the troughs, the lowest troughs are right around 10 degrees or so, and the highest peaks being around 16. So, but this has been our thousands of years up and down, if you will. And once again, going back about that 10,000 years for interglacial period. Now, if you look at the one on the right, smaller peaks, this is going from 1980 to probably, it looks like around 2018. I know that's when a lot of the data from this book is, 2018. And we see the basic rises and peaks, up and down and up and down and up and down. Once again, for climate, we want to look at a 30-year period. Well, guys, you can take virtually any section of that in a 30-year period, and what we see is a steady rise. Now, let's look at the numbers again. The lowest peak is sitting somewhere around 13.7, but our highest peaks up there are about 14.6. We're talking about our climate change. We're only talking about a couple of degrees. So we're looking at this, but that's the inescapable data that scientists are trying to look at. Any given year, we might get a drop, but when we look at this overall pattern, it's distinctively rising. Now let's look at another graph up here. In this one, we're looking at, on the far left, it starts down really low, and then we kind of get a big plateau, if you will. These are temperature changes over the past 22,000 years. So we go way back right there around, the year 10,000, we're going back 10,000 years, if you will. Then this is where we're coming out of an ice age. That's the end of the last ice age, where we're looking at a temperature changing in this case. And it comes up. And we see, that plateau is kind of sitting there. But of course, if you look towards the very end, we see where it's beginning to do this gentle rise. The chart on the right now, where it begins to peak a little bit at the far side, this is going from, the year 1000 up to now. So once again, at the very end of that, you see this very steep, sharp rise. And we're attributing that to burning of fossil fuels. We are burning more and more fossil fuels than we ever have before, and this is what is leading to our temperature change. Now, I think at a degree or two, here in Gainesville, so what? It goes from 95 to 97, because when we're talking about a degree, we're talking Celsius, not Fahrenheit. But a degree or two makes a big difference when you're in somewhere like Iceland, or you're somewhere at the poles, where the difference between ice and water is literally just a couple of degrees. And a couple of degrees of change releases an awful lot of ice and water into our oceans. And a lot of times this really is our concern. Now, these are kind of big. I'll try and put them down here individually, and we'll toss them up onto the side. What you're looking at here right now is Montana's Glacial National Park. This is a picture from 1913, so it's kind of black and white, but this is a picture of the glacial area, what is all covered in ice, 1913, and now, here it is in 2008, and drastically shrunk down. I'll throw them both up here so you can kind of look at it as a comparison. So, Montana's Glacial National Park, 1913 compared to 2008. It's a pretty far retreat of the ice, taken in the same time of the year. This is just what we're looking at. The data is there, the evidence is there. A lot of naysayers want to say, oh, it's not really happening, but it is, and it's all around us. Guys, that's it for today's. When we come back next time, we'll talk specifically about the causes of climate change. Take care.